Hi everyone. Today we're diving into the fascinating world of chemistry. Get ready to explore the fundamental building blocks of everything around us. Atoms. Atoms are incredibly tiny particles that make up every single thing you see, touch, and even breathe. Atoms have three main parts: protons, neutrons, and electrons. Protons are positively charged, neutrons have no charge, and electrons are negatively charged. The protons and neutrons hang out together in the atom's center, which we call the nucleus. The electrons are like tiny planets orbiting the nucleus in a cloud. Let's take the simplest example, a hydrogen atom. A hydrogen atom has just one proton in its nucleus, and one electron orbiting around it. It's like a tiny solar system. Atoms can combine with each other to form larger structures, which brings us to our next exciting topic, molecules. Section 2, Joining Forces, the Formation of Molecules. Atoms are sociable, they like to link up with each other. When atoms join together, they form molecules. A molecule is simply two or more atoms that are chemically bonded together. Think of it like this. Atoms are like individual Lego blocks, and molecules are the amazing structures you can build by connecting those blocks. There are two main types of molecules: elements and compounds. When the same kind of atoms bond together, they make up an element. For example, oxygen in the air we breathe exists as a molecule, with two oxygen atoms bonded together. We represent this as O2. Compounds, on the other hand, are formed when different types of atoms combine. Water is a classic example of a compound. It's formed when two hydrogen atoms bond with one oxygen atom, giving us the familiar H2O. Section 3. Weighing the tiny atomic and molecular mass. Now, let's talk about how we measure the mass of these tiny particles. We use something called the atomic mass unit, or AMU. One atomic mass unit is approximately equal to the mass of a single proton or neutron. The atomic mass of an element tells us the average mass of its atoms in atomic mass units. For example, the atomic mass of carbon is about 12 AMU. This means that, on average, a carbon atom is 12 times heavier than a single proton or neutron. To find the molecular mass of a molecule, we simply add up the atomic masses of all the atoms in that molecule. For instance, water, H2O, has a molecular mass of approximately 18 AMU. 1 AMU for each hydrogen atom plus 16 AMU for the oxygen atom equals 18 AMU. Section 4. Formulas and radicals. The language of chemistry. Chemists use special symbols and formulas to represent elements and compounds. These formulas are like a secret code that tells us exactly what atoms are present in a molecule. The molecular formula of a compound tells us the exact number of each type of atom in a molecule. For example, the molecular formula for glucose is C6H12O6, which means a glucose molecule contains 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Sometimes molecules have an unpaired electron. These molecules, called radicals, are very reactive. For example, the hydroxyl radical, OH, is important in atmospheric chemistry. We also use empirical formulas, which show the simplest whole number ratio of atoms in a compound. For example, the empirical formula of glucose, C6H12O6, is CH2O. So there you have it. Atoms and molecules are the fundamental building blocks of matter. Understanding these basic concepts is like having a superpower that allows you to unlock the secrets of the universe. Keep exploring and remember, science rules.